Hi, so for today we're going to talk about homogeneous DE with constant coefficients, auxiliary equation with distinct roots. Okay, so for homogeneous DE with constant coefficients, we have this form. Okay, we have a sub o d raised to n y over dx raised to n, which is the nth derivative of y with respect to x, and plus another constant a sub 1 multiplied by the another derivative, lower order derivative of y with respect to n, and so on and so forth until we have a sub n minus 1 dy over dx plus a sub n y is equals to 0. So homogeneous d with constant coefficient is in this form. But this form can be rewritten as in the form of f of d y, okay, f of d multiplied by the dependent variable, which is y is equals to 0, where f of d is actually what we call the differential operator, okay? And if we let y is equals to e raised to n, okay, multiplied by x, we have this form, f of d multiplied by e raised to m of x, m raised to x, e raised to m x is equals to 0. And if we are going to substitute, okay, f of m in place of the differential operator d, we'll be having f of m is equals to 0 if and only if m is a root. So we see that in solving polynomials, in getting the roots of a polynomial, when we multiply or when we substitute the value of a root in a certain polynomial, if that certain number or root is a root of the polynomial, the result is always 0. So that's what we are going to recall here. Okay, so we are going to recall our skills in solving the roots of a polynomial equation, because that's how homogeneous DE with constant coefficients is being solved using the auxiliary equation in the first case of distinct root, okay, in this video. So what will happen if we have this form now? This is an auxiliary equation. Let its root be m1, m2, and m3. Then the solution to that homogeneous DE with constant coefficient is this. For the distinct roots, it means that we have different roots, because we have actually four types of roots. We have distinct, okay, we have repeating, imaginary, actually, and non-repeating, if I'm not mistaken, at least three. So for this video, I'm going to show you the solution for a distinct root. So wherein we have y is equal to the solution to differential equation. This differential equation is this. So y is equal to c sub 1 e raised to m1, where m1 is one root uh, of the differential equation, plus c sub 2 e raised to m sub 2 multiplied by x, plus c sub 3 e raised to m sub 3 x, plus and so on and so forth. How many roots? C sub n e raised to m sub n multiplied by x, where c sub 1, c sub 2, c sub 3, and so on and so forth, c sub n, are what we call the arbitrary constant. So for us to really fully understand this, I will give you several examples, right, in order for us to solve this. So how do we solve this differential equation? Okay, so we have the third derivative of y with respect to x minus a constant coefficient, okay, in our differential equation, minus 4 multiplied by second derivative of y with respect to x plus dy dx plus 6y is equals to 0. First, we need to convert this into the differential form. Okay? So in the differential form, f of d multiplied by y. So as we can see here, we can substitute this as d cubed, because its third derivative multiplied by y, that's the dependent variable, minus 4d squared, okay, multiplied by y, okay, because that's a dependent variable, and we have plus dy over dx, of course, that's the y, okay, plus 6y is equals to 0. Okay, so what will happen here, if we factor out y, we have d cubed minus 4d squared plus d plus 6, okay, and multiplied by y is equals to 0. Now notice we have written this form into this form. Okay? Okay, in this form, in differential form. Okay? So what are we going to do next is we're going to put it on what we call the auxiliary equation, wherein we will let this d equal to m, okay? Because this y is equal to e raised to m x. So what will happen? Putting these differential operators into its m, what will happen is that we have m cubed minus 4m squared plus m, okay, plus 6 is equals to 0. So what happens next is we are going to find the roots of this equation, okay, auxiliary equation. So how are we going to find the roots? Okay, the root is when we substitute that value of the root in this auxiliary equation, it must be equal to 0. So how do you find the root of this? Well, of course, we have rules in finding the roots of a polynomial. Okay, so as we can see here, this would be our q, and this would be our p. Okay, the all of the possible roots, all possible roots is given by the equation, okay, p over q, meaning, okay, all of the multiples of 6 and all of the multiples of the coefficient of m cubed 1 is the possible uh, root of this polynomial equation. So we have, for number 1, we have positive negative 1, positive negative 2, positive negative 3, okay? Or positive negative 6 over the cube, all possible multiples. So that's only 1, positive or negative 1. So what will happen here? Taking a guess, okay? But for me, I would guess that, let's say that that is a positive 3 over 1. So 3 over 1 would be, let's say, you can do this by trial and error, okay? If the result is 0, okay, then by synthetic division, if the result is 0, then that is a root. So let's pick 3. And I'm going to perform what we call the synthetic division, wherein I will copy, okay, I'll copy the coefficients, okay, of each term. For m cubed, we have 1 m cubed. For m squared, we have negative 4. For m, we have 1. Okay, and for the constant, we have the 6. The very first thing we're going to do, recalling our synthetic division, is to bring down 1. Okay? So what we're going to do is to bring down 1, the very first constant here in our synthetic division. So what are we going to do is, we're going to multiply this by this. So 1 times 3 is 3. Okay? And simply add 2. So what will happen? We have negative 1. Okay? And negative 1 multiplied by 3 is negative 3. And what will happen? We add this to 1 plus negative 3 is negative 2. And what will we do again for the last time is to multiply this negative 2 on the 3. So we have negative 6. And if we add this, 6 minus 6 is 0. Therefore, okay, one of the roots, m sub 1, is actually the 3. Okay, this 3. Okay, because it has, when we divide this 3 in our equation, okay, we get a 0 here, which means that this is a root. Okay, so you gotta recall your knowledge about synthetic division. So we have m1, but notice that we are raised to a third degree, so therefore we have 3 roots. So we gain already the 1. Okay, and the other roots is gained by this equation. Okay, so let's try. Okay, what will happen if we recall, if we do synthetic division? Okay, so whatever the coefficient here, these are coefficients. So we would actually have a minus in the degree when we try to find this equation. Okay, so what will happen is that this one has a coefficient of 1, m squared, okay, because we divided it by another factor. So this cube reduces to square, wherein we have a positive 1 as our constant here, and we have negative, okay, m, okay, because that is in order. Okay, second degree, first degree, no degree, and this is the constant. So what will happen? We have negative m, or negative 1m, or minus 2 is equals to 0. In other words, our equation reduces now to m squared minus m minus 2. And if we is equals to 0. And if we are going to factor out this, okay, that is equal to m, okay, m minus 2, okay, times m plus 1 is equal to 0. So the roots, the other roots, m sub 2 is equal to 2 and m sub 3 is equal to negative 1. Okay? So here are the roots. We have m2 is equal to 2, m3 is equal to negative 1, and m1 is equal to 3. So what are we going to do? We write now it in the form of c sub 1 e raised to m sub 1 x plus c sub 2 e raised to m sub 2 x plus c sub 3 e raised to m sub 3 x. So what will happen again is that we have y, because that's the dependent variable. Okay, notice that this is not always equal to y. So this term or this variable is indicates what is the dependent variable in our given differential equation. So for c sub 1, we don't know that. That is an arbitrary constant. So e raised to m sub 1, our m sub 1 is 3x plus c sub 2, that's an arbitrary constant, e raised to m sub 2, 2x plus c sub 3, e raised to m sub 3 is negative 1, so this would be negative x. So this would be our solution to the homogeneous linear D with constant coefficient, okay, for our first example. Notice that we can also, okay, notice that we have distinct roots. We have 3, 2, and negative 1. Hence, we are solving for distinct roots for this video. Okay, for the upcoming video, we're going to have repeated roots. We're going to have imaginary roots. But for now, we're going to have distinct roots, meaning the roots are not the same. So, or we can also rewrite this as, you can also rewrite this as, doesn't matter if you label this as m sub 1, m sub 2, m sub 3, or this one m sub 1 and m sub 3, or this one m sub 1, m sub 2, as long as you write this in this form. Or we can have an answer c sub 1 e raised to negative x plus c sub 2 e raised to 2x, okay, plus a c sub 3 e raised to 3x. That is still the same as the first answer, okay? So that is still the same. So for second example, okay, for a second example, we have already this differential equation written in differential operator form, d squared plus 2d minus 3 multiplied by y is equals to 0. So there's no problem with this since this is already written in differential operator form. What will happen? We're going to convert it into auxiliary form. So that we have m squared plus 2m minus 3 is equal to 0. Okay? And if we are going to find the roots of this, okay, that's m plus 3, okay, multiplied by m minus 1. If you perform FOIL here, you'll get this answer, okay, is equals to 0. We are after what is the root. So since this is a second degree, we have two roots. So as you can see here, we have the root. One is negative 3, and the other root, m sub 2, is 1. Okay? So, rewriting that in our form, okay, of distinct root, solution to distinct root, notice that this is still y because this is the dependent variable. Okay? So, we have c sub 2 e raised to m sub 2 x. Distinct roots, we have negative 3 and 1. So, we have y is equals to c sub 1 e raised to negative 3x plus c sub 2 e raised to 1 times x, which is simply this. Okay, this is our answer. Pretty easy, right? Okay, or we can interchange this. We have m sub 1 is equals to 1 and m sub 2 is equals to negative 3. Doesn't matter. So we have c sub 1 e raised to x, okay, plus a c sub 2 e raised to negative 3x. That is still the same. Okay. Okay, for number 3, let's try another one. So we have d squared plus 2d multiplied by y is equals to 0. So take note that this is already in differential form. We need to convert this into auxiliary equation. So m squared plus 2m is equal to 0. Okay, so finding the roots of this, I can factor out m. We have m plus 2 is equal to 0. As you can see here, m sub 1, this is equal to 0. And another root m sub 2 is equal to negative 2. Hence, if we are going to rewrite this, the solution of this DE, okay, to this DE is this. We have two roots, so we have m sub 1 and m sub 2, and we substitute that. We have c sub 1 e raised to m sub 1, which is 0 times x, plus c sub 2 e raised to negative 2x, okay? We know that e raised to 0, okay, times x is simply 1. So, on our final answer, we have y is equal to c sub 1 plus c sub 2 e raised to negative 2x. And this is the solution to our differential equation. So, let's try again another problem. So, number 4, we have d cubed plus 6d squared, okay, plus 11d plus 6 multiplied by y. Putting this first into auxiliary equation, we have m cubed plus 6m squared plus 11m plus 6 is equals to 0. So we have the q, the coefficient of this is 1, and we have the p, okay? And the possible roots is p over q, the multiples of p over q. We have p is positive negative 1, positive negative 2, okay? The multiples of this, positive negative 3, and positive or negative 6 over the q, which is positive or negative 1. So, let's try a guess. If you didn't get the roots, okay, it's possible that it's 1, it's possible that it's 2, negative 2, 3, negative 3, 6, negative 6. So, you're going to have a trial and error on this, okay, in order for you to solve some roots. So, let's say I'm going to try negative 2. Okay, one root is negative 2. I'm going to try. So again, I'm going to copy the coefficients of this. Coefficients of this, we have 1, we have 6, we have 11, and we have 6. Bring down the first one. Okay, so I'm going to bring down the first one. Let me just have a little space here. Okay, so I'm going to multiply this by this. We have negative 2. 1 times negative 2 is negative 2. Then add this. I'm going to get 4. 4 times negative 2 is negative 8. 11 plus negative 8 would be 3. So 3 times negative 2 is negative 6. We add this. 6 minus 6 plus negative 6 is 0. Therefore, 1 root m sub 1 is negative 2, which is this, because it results to a 0 remainder. Okay? So, what are we going to do? We're going to get the equation again of this. So, what will happen? This is the coefficient now of m squared, coefficient of m, and this is the constant value. So, we have m squared plus 4m, okay? This is that, plus 3 is equals to 0. Now, again, we have 3 roots since this is raised to 3. So, definitely, we should get the 2 other roots. Okay, so we can have this by m plus 1, factoring this, m plus 3, okay, is equals to 0. So, we have m sub 2 is equals to negative 1, and m sub 3 is equals to negative 3. And as you can see here, we have the complete roots. We are ready to write the solution to this differential equation, c sub 1 e raised to m sub 1x plus c sub 2 e raised to m sub 2x plus c sub 3 e raised to m sub 3x. And what will happen here is we have y is equals to c sub 1 e raised to m sub 1, which is negative 2x, plus c sub 2 e raised to m sub 2 is negative x, since negative 1, plus c sub 3 e raised to negative 3x. So this is the solution for our homogeneous linear differential equation with constant coefficient. So let's try now to a fourth degree equation. Okay, so this is, I think, number 5. Okay, so we have 4d raised to 4 minus 8d cubed minus 7d squared plus 11d plus 6 is multiplied by y is equals to 0. So converting this into auxiliary equation, we have 4m raised to 4 minus 8m cubed minus 7m squared plus 11m plus 6 is equals to 0. Again, in order for us to find the possible roots of this, we have the q, the constant coefficient, constant of the highest order, m raised to 4, and we have p, and the set of all positive or the set of all possible roots of this is the multiples of q and x, or 6. So we have what? For p, we have positive 1, negative 1, positive negative 2, positive negative 3, positive negative 6, over q, positive negative 1, positive negative 2, positive negative 4. Okay, so you have to take all of this, and you have to pick. Okay, if you're lucky enough, you can pick a number here. Okay, here divided by this. Okay, and you're going to have a root. So let's take note, or let's try -1. So what will happen if I pick 1 and -1 here, or -1 on the numerator over +1? That is a -1. Okay, that's one possible combination, or one possible root. Okay, that's the -1. Again, copy the constants. We have -8, we have -7, we have 11, we have 6. Bring down the first one. Okay, and then multiply this by this. That should be -4, and add this to -8 plus -4 is -12. -12 times -1 is 12. Oh, -7 plus 12 is actually 5. 5 times -1 is -5. So 11 plus -5 is 6. Right? 6 times -1 is -6. So 6 plus -6 should be 0. So therefore, we have m sub 1 is equals to -1. That's a root. Okay? So this is the reduced polynomial. So we can rewrite this as, this is the coefficient of m cubed, m squared, m, and the constant. So we have 4m cubed, okay, 4m cubed minus 12m squared, okay, plus a 5m plus 6 is equals to 0. Notice that we are raised to 4, so we have 4 roots. And again, we can label this again as our q, and this is our p. Okay, as you can notice here, 4 and 6, still we have this possible combination of roots. Okay, so if I'm going to choose, let's say one possible combination is -1. I pick -1 here, and +2 on the denominator, such that I have -1/2. So -1/2 as my root. Okay, I'm going to write this again, the constants. We have 4, -12, and we have 5, we have 6. Okay, the very first thing is we're going to bring down this and multiply this by this. 4 times -1/2 is -2. We add this 2, we have -14, and -14 times -1/2, that would be a +7. Okay, and we have 5 plus 7 is 12. And of course, 12 times -1/2 is -6, such that if we're going to add this, that would be 0. So therefore, again, we have an m2, since it equates to 0, since the result when we divide this is 0 here, okay, on the very last term, no remainder, then that is a root. So m sub 2 is -1/2. So that's a root. So this is now our reduced equation. The coefficient of this of m squared, the coefficient of m, and the constant value. So what we have therefore is this. We have 4m squared minus 14m plus 12 is equals to 0. Notice that it's very hard to factor. And what I'm going to do here, I'm going to use quadratic formula in order for me to find the roots of that. Okay? So wherein my A is 4, my B is -14, and my C is 12. Okay? So notice that we can get the M. as negative of negative 14. Okay? Plus or minus, we have b squared negative 14 squared minus 4 times a times 12. Okay? Over 2 times 4. So, what are we going to do here? If we take first the positive, okay, so negative times negative would be 14, positive first, later on the negative, okay. So, what will happen? 14 squared is 196, and if we multiply this, all of this, that should be minus 192 over 8. And if we are going to evaluate this, this is x sub 1 because we have x sub 2, which is the minus. So, we have 14 plus 196 minus 192 is 4. Square root of 4 is 2 over 8. We have 16 over 8, and that is equal to 2. So this is the m sub 3, the other root. How about the fourth root? X sub 2, we have 14. Again, we take plus here. We take negative here, minus here. Okay, and that is still the same. 196 minus 192 over 8. So what will happen? X sub 2 would be 14 minus, okay, 2 over 8. And that is 12 over 8. And that is what? 3 over 2. Okay? By lowest term. So this is now our fourth root. Okay? So if we rewrite again our roots, we have m sub 1 which is equal to negative 1. We have m sub 2 which is equal to negative 1 half a while ago. M sub 3 we have 2. M sub 4 we have 3 halves. Okay? So we can see that these are distinct. Not repeating, all are distinct. All are unique roots. So we can rewrite this in our solution. We have c sub 1 e raised to m sub 1x plus c sub 2 e raised to m sub 2x plus c sub 3 e raised to m sub 3x plus c sub 4 e raised to m sub 4x. Okay, if we're going to substitute that, we have y is equals to c sub 1 e raised to negative x plus c sub 2 e raised to negative 1 half x plus c sub 3 e raised to 2x plus c sub 4 e raised to 3 halves x. And this is the solution to our differential equation using auxiliary equations. Okay, down for our last example for this video. Okay, so for number 6, solve the equation. Okay, second derivative of x with respect to t minus 4x is equal to 0 with the given condition. Okay, given condition that when time is equal to 0, x is equal to 0, and the derivative of x with respect to t is equals to 3. Okay? So first, what we're going to do is to write this into auxiliary equation or differential operator. So we have d, okay, squared x. Notice that a while ago we have y here because y is dependent variable, but now it's x, so it must be x. So minus 4x is equals to 0. 4x only because this has no derivatives in it. Okay, so we have to factor x, so we have d squared minus 4 multiplied by x. That's the differential operator. Converting this into auxiliary, okay, so we have what? We have m squared minus 4 is equal to 0. If we're going to get the roots, m sub 1 we have positive 2, okay? M sub 2 we have negative 2 because if we transpose negative 4, it would become positive 4. Getting the square, we have positive 2 and negative 2. Okay, so what is our solution? So our solution, the dependent variable now is not y but x is equal to c sub 1 e raised to m sub 1 t, since now the independent variable is t. Okay, a while ago it's x, so now it's t. So it's not always x, okay? And this is not always y. It depends on the differential equation. It's dependent and independent variable. This is the dependent, this is the independent, okay? So plus c sub 2 e raised to m sub 2 times t. So we have x is equals to c sub 1 e raised to m sub 1, which is 2t, plus c sub 2 e raised to negative 2t. So this is our solution to the differential equation, but we have a given condition. So if we have a given condition, we can solve for the values of c sub 1 and c sub 2. Okay? So we want to have a particular solution in this. So let's try that. It says on the given condition, at time is equals to 0, x is equals to 0. So we simply substitute this value. So we have 0 is equals to c sub 1 e raised to 0, 2 times 0, okay? So times 2, so let's write, plus c sub 2 e raised to negative 2 times 0. What will happen? E raised to 0 is simply 1, e raised to 0 is simply 1. We are left with 0 is equals to c sub 1 plus c sub 2. And this is our first equation. Okay? The second equation comes from the second condition that when time is equal to 0, okay, when time is equal to 0, again, it says, this is when time is equal to 0, x is equal to 0, and dx over dt is equal to 3. So when time is equal to 0, dx over dt is equal to 3. So from our x, this is our x, okay, we have c sub 1 e raised to 2t plus c sub 2 e raised to negative 2t. So if I'm going to get the derivative of x with respect to t, what will happen with respect to t is that we have 2 c sub 1 e raised to 2t. Okay, that's very easy. And we have plus negative 2 c sub 2 e raised to negative 2t. So rearranging that, simplifying, we have 2c sub 1 e raised to 2t minus 2c sub 2 e raised to negative 2t. Okay, but take note that when t is equals to 0, dx over dt is 3. So we have 3 is equals to 2 c sub 1 e raised to 2 times 0, because time is equals to 0, minus 2 c sub 2 e raised to negative 2 times 0. This simply becomes 1. This simply becomes 1. So we have 3 is equals to 2 c sub 1 minus 2 c sub 2 is equals to 3. Okay, so this is simply our second equation. Okay, so what are we going to do is simply, okay, if we had this equation, 0 is equal to c sub 1 plus c sub 2 as our first equation, and this is our second equation, I can get c sub 1 here, which is equal to negative c sub 2. And if I'm going to substitute c sub 1 here as negative c sub 2 on this equation, we have 3 is equal to 2 times negative c sub 2 minus 2c sub 2, so that we have negative 2c sub 2 minus 2c sub 2, we have negative 4c sub 2 is equals to 3, and then finding the value of c sub 2, that is negative 3/4. Okay, and the value of c sub 1 finally is simply the negation of negative c sub 2. So we have negative 3/4, so that becomes positive 3/4. So what we're going to do is the arbitrary constant now are defined. So we're going to substitute it back here. So x is equals to c sub 1, which is 3 over 4 e raised to, okay, this e raised to 2t minus 3 over 4, that's the value of c sub 2, e raised to negative 2t. Okay, so what will happen is that if we are going to factor out 3 over 4, so we have 3 over 4 e raised to 2t minus e raised to negative 2t, and I'm going to factor out 1/2 here. So we have 3 over 2 times 1/2. That is still the same. 3/2 times 1/2 is 3 over 4. Okay? So what I'm going to do is this. And I'm going to multiply this by this such that I have 3/2 is equal now to e raised to 2t minus e raised to negative 2t over 2. Now, this is an identity, the Euler's identity, such that when we studied hyperbolic sine of x, that is equivalent to e raised to x minus e raised to negative x over 2. But since it has 2 in it, okay, so hyperbolic sine of 2x would simply be equal to e raised to 2x minus e raised to negative 2x over 2. But in this case, we have a variable which is t. So this is simply now equal to the hyperbolic sine of 2t, wherein we have e raised to 2t minus e raised to negative 2t over 2. So what will happen is that we have x is equals to 3 halves. Okay? Hyperbolic sine of 2t, that's our answer for this problem. So thank you so much for listening. I hope you guys learned something for today. This is Engineer Abat. This is a tutorial video on the auxiliary equation with the distinct roots. Thank you so much for listening and God bless you.